to welcome you to Thesis 1, Presentation 1. I would like to start by introducing my group members, Amr Aweda, Fatima Badir, Noor Adib, and myself, Michael Thomas. I would also like to introduce our advisors, Dr. Mohammed Naguib Abu Zaid, Engineer Minas Asad, and Engineer Amr Fathi. Today we will be talking about the properties and feasibility of using Egyptian limestone cement in Portland cement concrete. From now on, we will be referring to Portland cement concrete as PLC. This is a brief list of our outline. We are going to be discussing a brief history or background of Portland limestone cement. We will discuss the objective and scope, the approach we are going to take for our experimental procedure, the outcomes we expect to achieve by the end of our work, and we will discuss the challenges we might face, and we will also show a tentative time schedule of our work. Currently, global CO2 emissions are the highest they've ever been and are continuously on the rise. Furthermore, our energy supply is depleting and at a faster rate than ever before. The construction industry alone emits about 40% of global CO2 emissions. Thus, the cement industry has looked at other alternative solutions for replacing clinker, said to be the most responsible for CO2 emissions in the cement industry, with other materials, such as silica fumes, slag, pozzolanic materials, and limestone. Limestone would represent the best option or best replacement for the Egyptian market due to two main reasons. It is relatively low cost compared to other materials. It is also very readily available and abundant in Egyptian soil. The graph here shows a very obvious trend of global cement consumption and an obvious growth rate. This has obviously an equally adverse effect on our environment and an equally adverse rise in CO2 emissions. The table here shows clearly that Egypt ranks 25th in a list of countries in terms of CO2 emissions due to two things: the cement industry and the burning of fossil fuels. This is further substantiated by the graph shown here, where we see an obvious rise with time in the consumption of fuels and CO2 emissions due to the cement industry in Egypt.
Energy consumption is another concern for the cement industry. One of the big problems Egypt is facing, specifically the Egyptian industries, is the supply of energy and optimization of use. And as you can see here, there is an increasing trend in this graph for the electric consumption per capita in the local industry. By reducing the clinker amount and adding limestone in the cement by dosages such as 10% limestone or 15% limestone, we expect electricity reduction by an amount of 7 million kilowatt-hour per million tons of cement. This is for the 10% limestone. Also, we expect in CO2 emissions reductions by an amount of 200,000 tons per million tons of cement. The main idea is that clinker is an early stage of cement. It's produced or manufacturing by the heating of raw materials that we acquire from quarries, such as limestone and clay. This process originates CO2 emissions due to the calcination from the process of calcination of limestone, as well as the burning of fossil fuels. So in order to reduce that negative impact on our environment, in our scope of work, we're going to reduce the clinker and add limestone with specific dosages, and add limestone in order to produce equivalent amount of cement needed. This thing is called the limestone cement. Limestone cement, it's not new. This is from the outline shown here, that in 1965, Heidelberger produces 20% limestone in Germany for use of application in special use. And as you can see here, in 2004, ASTM and the ASHTO have allowed for 5% limestone in types of cement from 1 to 5. Then in 2012, they have increased their dosages of limestone to allow to 15%.
As Noor was just saying, PLC is not new and has been used in many other countries. So, however, it has never been used in Egypt. So accordingly, our objective is to assess the performance of PLC cement, Portland limestone cement in Egypt, and to examine its merits for use in structural concrete. The scope of our work will be concerned with two categories of concrete, normal strength concrete and high strength concrete. And the tests that will be done for each will be fresh concrete tests, hardened concrete tests, and durability tests. The following outlines our experimental approach. We're basically going to have a producer one, under which we're going to have three main categories for concrete design, for concrete mixes. The first one is a conventional type, which will be used as a benchmark for comparisons. Second one will be cement with limestone of dosage A, and the third one will be cement with limestone of dosage B. Under these three main categories, we're going to have three concrete mixes. The first one will be normal strength concrete with a water to cement ratio of 0.5. The second one will be high strength concrete with water to cement ratio of 0.3. And the third one will be high strength concrete with water to, the second one will be high strength concrete plus a super plasticizer. The third one will be high strength concrete with a water to cement ratio of 0.3 plus a super plasticizer plus silica fumes. We're also going to have a second producer, and he's going to supply us with cement with limestone of dosage A and B. And this second producer will basically act as a verification of our results. However, we're going to limit the experimental work for the second producer, as we won't have the luxury of time to conduct all these tests again for another producer. We're going to conduct experimental tests on cement. So the first one will be a setting time test, a fineness test to see how fine the particles are, and a compressive strength test to see the binding strength of cement. The following are the tests that will be conducted on concrete. We're going to have for fresh concrete, we're going to have a unit weight test to determine the weight per unit volume. We're going to have a slump test to assess the workability. And we're going to have a slump retention test to assess whether the concrete can withhold itself or whether the slump, we lose it quickly. We're also going to have an air content test to determine the percentage of air, and a temperature test. For hardened concrete, we're going to have a compressive strength test for 3, 7, 28, and 56 days if we have time. If not, we're just going to keep it as long as possible. We're also going to do a flexural strength test to determine the resistance against bending, and a bond strength test to determine the bonding strength between steel and concrete. We're also, for long-term tests, we're going to have a sulfate resistance test, a rapid chloride permeability test, and a corrosion test. We also want to calculate the CO2 emissions of our mixed designs, and this will be done using a model that has been previously developed by AUC students. We're going to take this model, develop it in order to fit our scope of work.
Here is what we expect to achieve after we've conducted our tests. We expect to achieve a better understanding of PLC and how applicable it is in Egypt. We'll also be hoping to provide potential contribution to CO2 emissions and the energy consumption problem. As we have seen earlier in the graph, that there was a clear increase locally in Egypt. Also, we'd be looking to through the test, we'll be looking to see if it could be, in fact, be approved by the Egyptian Concrete Code, which will help pave the way for widespread use of the PLC here in Egypt. Here are a few challenges that we expect to encounter during the research. Since it's a new material, so the procurement of materials on time might be a challenge. Also, we don't know what we really should expect, since it's a new material that has never been tested before in Egypt. And the availability of different testing facilities. We'll have to manage our time really well, especially if we want to conduct all the tests that we mentioned on the specified time. And due to our current political instability in the country, we might encounter some potential interruption of work. Here's a graph that shows our time schedule, which we divided in weeks. As you can see, the 3 dots on the graph represent the first, second, third, and final presentation. Here are some of the references that we used.
Thank you. Questions? Mr. Chief? Now, are you going to tell us the economic part of this project? I mean, how much will you save? You are saying that limestone is found in Egypt, so you're going to save money, you're going to save energy. Are you going to include this in the report, how much of the cost of this?
Yes, we did not say this, but with the model that shows the CO2 emissions that was done previously by AEC students, they also developed an economic model to calculate the cost. So we're also going to take this model and adjust it to fit our scope of work.
Okay, now you said among the tests that you're going to do in the fresh concrete, you have temperature. You mean heat of hydration?
No, it's just, yeah, basically to determine just if it exceeds 30 degrees, it would be a problem for cracking. So we just said, it's just a,
For the working conditions in Egypt, weather conditions.
Okay, so this has nothing, it's not the heat of hydration. It's also good to see how much the value of heat of hydration compared to conventional cement that we can compare the properties. I mean, if it will have an impact on shrinkage or something like that. Also, I have a last question. The producer, did you name the producer who will give you this kind of cement?
We're still in contact.
Did you name them? Do you know them?
yes,
Yes,
we know
yes.
too.
Yes, we know too, and we're having like meetings by this week and next week.
He's producing this commercially, or he will provide you with this?
No, there's one of the producers, we started to produce that commercially, but no, it's not commercially. It will be for our use for the specific dosages we want. So it's for us, I'm sorry, it's for us.
So you know him?
Yes,
Yes.
Who is the producer?
We have two companies, including the Suez Cement and the Forge. We've already made contact with them and we have meetings this week.
Chief, I just want to say something also for our colleagues here and the students. That's a very early stage by the factories themselves, and it's to their interest that we do this work because we want, if this thing works,
Of course.
yeah, it's to their interest. Yeah.
Just one question. Do you think it is instructive to use or informative to use to do some mortar tests on this kind of cement instead of concrete or besides concrete tests?
Thank you for the question. With the topic of the scope of our work is only limited to testing Portland limestone cement as structural concrete. It would definitely be nice to test it and see its mortar capabilities. However, due to the time constraints and facilities we have, we will only be limiting our work to testing Portland limestone cement as a structural concrete component.
Do you intend at the end of your work to have some kind of code recommendation to use this type of cement or no? And whether you recommend to use it, is it for above ground structure or underground structure?
Yes, we would love to do something like that because like Portland limestone cement, it also has disadvantages and limitations such as the sulfate resistance and its use in foundations. So that's why we're doing our durability tests of the sulfate resistance and other tests. And the literature said that specifically in that area there were mixed results and encouraging results, and tests are needed. So that's why we were encouraged to do the durability test for that reason.
Thank you. Any other question? Okay, thank you.